My name is Heather Brosmahan. I am a graduate student at Ohio University in the Department of Geological Sciences, and this is a brief overview of what I think we know about the geology of Mars. The earliest period in Mars history is referred to as pre-Noachian time. Little is known from this era other than Mars accreted and differentiated into crust, mantle, and core within a few tens of millions of years of the formation of the solar system. Mars' equatorial radius is roughly half that of the Earth, the length of a year roughly twice that of the Earth, and the length of day is nearly the same. The core of Mars is likely liquid, and according to analysis of Martian meteorites, is comprised of iron, nickel, and sulfur. During the pre-Noachian, impactor flux was at an all-time high. Subsequently, Mars experienced numerous large basin-forming impacts, several of which may have facilitated the topographic low of the northern hemisphere. Vigorous convection in the core during pre-Noachian time resulted in the generation of a dynamo, as evidenced by remnant magnetism detected in the southern highlands. Magnetism of equal magnitude has an east-west trend similar to that which is observed on Earth relative to spreading ridges, and may therefore be indicative of an active plate tectonic regime. At this point, I would like to introduce some nomenclature that will be used on the preceding slides. Fossae are linear tectonic depressions analogous to terrestrial graben. Mons refers to a large isolated mountain or shield volcano. Paterae are circular volcanic depressions. Planitia are plains. Terra is an expanse of land, and vallis is a valley. These terms are included in geographic names and denote the type of feature which is being referenced. The following slides present geologic history in a format similar to a stratigraphic column, where the events on the bottom of the chart happened before the events on the top. The base of the Noachian period is marked by the formation of Hellas Impact Basin, and occurs between 4.1 to 3.8 billion years ago. High rates of cratering, erosion, and valley formation are characteristic of this time period. Highland volcanism was widespread, and as was the generation of tectonic fossae. The formation of extensive valley networks, interpreted as fluvial channels, was primarily active in the late Noachian. Intense heavy bombardment of impactors continued until the late Noachian, and erosional and superficial processes were at an all-time high. The widespread production of weathering products, such as phyllosilicates and geomorphic evidence of lakes and rivers, suggest that the Noachian may have episodically experienced warm and wet conditions. This period ends around 3.7 billion years ago. Geologic activity during the Hesperian period was dominated by volcanism, which resulted in the displacement of extensive lava plains. Although several canyons and large outflow channels formed during this time, the surface conditions were not favorable to aqueous erosion or weathering. This period is also marked by the accumulation of sulfate-rich deposits. The Amazonian period, beginning around 3 billion years ago and continuing into the present, has been an era of extremely low erosion and weathering rates. Impact cratering, tectonism, and volcanism have also been only occasionally active. As a result, ice and wind superficial processes have become more evident. it is important to note that the Amazonian period accounts for 2/3 of Mars' geologic record, yet the majority of geologic activity was in the planet's first 1.5 billion years, which was during the Noachian and Hesperian periods. That leads us to our current understanding of the red planet, a name given to Mars on account of the highly oxidized surface. Presently, Mars has a distinct dichotomy, which is a temporal and topographic asymmetry between the northern and southern hemispheres. The older and topographically high material is located in the south, and the younger, topographically low material is located in the north. This figure demonstrates topographic differences where the reds and oranges are areas of high elevation, and the blues and greens represent low elevations. Another interesting aspect of Martian geology is that the crustal composition doesn't vary across geologic time terrains. Basalt is the primary rock type found on Mars' surface, with a global mineralogy dominated by calcium-rich plagioclase and pyroxene. In conclusion, Mars has experienced global-scale geologic changes that were most active during the Noachian period and have continued only episodically into recent time. The current state of Mars appears to be relatively inactive, except for superficial processes such as ice and wind, but even these are at lesser rates than in the past. Ultimately, our understanding of Mars has developed significantly since early telescopic observations, but undoubtedly still has a very long way to go. Thank you for your time.